Okay, so this is the video for section 5.1, and we are going to be talking about the steps to approximating the area under your curves. So we have been dealing with functions, and then we take the derivative of those functions, and we get the slope of the tangent line. Now, this symbol is integrate, and if we integrate the function, what does that help us determine? So what it's going to help us determine is how to find the area under the curve. Okay, so for instance, if you're looking at this picture, we have a car trying velocity to do our displacement by d equals r2. And in this case, of a rectangle because it's horizontal. So it's relatively for us to find the area of this because we know that the area of the angle is length. So in 60 miles per hour times r2 gives us 120 miles. Right? Now we're going to be nice graphs that are and the answer is no. What happens? Okay, so we have a function v equals t squared. Okay, our interval is from 0 to 8, and it wants to approximate the displacement by dividing this into n subintervals of equal length. So in this case, n is 2, which means I'm going to divide this into 2 equal pieces. And then on each subinterval, we're going to find the midpoint, and we're going to use that to evaluate. Okay? So what you need to think about is you need to think about how can I divide this exactly into 2 equal pieces. So what you would say is this one seems a little bit silly because one of our numbers is 0, but essentially you're going to subtract those 2. And then since we have 2 intervals, we're going to divide that by 2, which means I'm going to have a length of 4. Okay, which means my 2 intervals are going to be one from 0 to 4, and the second one is going to be from 4 to 8. Okay, so the next thing that we're going to do is we're going to find the midpoint of each of these 2 pieces. So in order for me to find the midpoint is essentially like taking the average. So what I'm going to do is I'm going to add these 2 pieces together, and I'm going to divide by 2. So my midpoint for the first one is 4 divided by 2, or 2. And then I have 4 and 8, so I'm going to add 4 plus 8, which is 12. And we're going to divide that by 2 to get 6. Okay. So what we're going to do is the rule when we're doing this is you're always going to multiply your length by the value substituted in. So we're going to do the length times whatever values you get. And you're going to add all of them together. So in this case, I've got 2, so I'm going to add them together in here. So my length was 4. And my 2 midpoints were 2 and 6. So what I'm going to do with my 2 and my 6 is I'm going to plug it in here. So we're going to do, let me switch to this color, 2 squared to give me 4. And we're going to have 6 squared to give me 36. So in my parentheses here, I'm going to add 36 plus 4. And I'm going to do that first before I multiply that by my length. Okay, you could do it individually in this case, but if you do that, you're going to get 160 meters. Okay. All right, now let's see what happens when we take the same problem, but we divide it into more subintervals. Okay, so we're doing the same exact problem, except this time I have 4 subintervals. Okay, so I'm going to find my length first. So remember, I'm going to do the numbers subtracted, which is 8 in this case, and I'm dividing that by 4 this time. So that's going to give me a length of 2. okay? So we are still dealing with the midpoint. So let me go ahead and split these guys up. So we're going to start with 0. Our length is 2, so we're going to 2. And then we have 2 to 4. And then we have 4 to 6. And then we have 6 to 8. Okay. All right, the next thing that we're going to do is we're going to find our midpoint. Okay, so 0 plus 2 is 2, divided by 2 is given me 1. 2 plus 4 is 6, divided by 2 is 3. 4 plus 6 is 10, divided by 2 is 5. You see the pattern? 6 plus 8 is 14, divided by 2 is 7. Okay. Now the next thing that I'm going to do just to make my life a little bit easier is I'm going to go ahead and plug these midpoint values into my function. So I'm going to do 1 squared, which is 1. 3 squared is 9. 5 squared is 25. And 7 squared is 49. So what I'm going to do is I'm going to take my length of 2 and I'm going to multiply that by the sum of 1, 9, 25, and 49. Okay. So if I do that, I'm going to get 168 meters. All right. Let's do it again. All right, so for this next one, it wants 8 subintervals. So this is a little bit silly for me to write the math out, but I'm going to do it anyway. Because if I divide 8 by 8, I'm going to get a length of 1. Okay, so that means my intervals are 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. Okay. And we're still dealing with midpoint again, so I'm going to go ahead and find the midpoint. So in this case, it's going to be 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, and 7.5. Okay, and then I'm going to go ahead and substitute that in for my velocity as well. So remember, we're going to square the values. So I'm going to get, actually, I didn't write any of that down. I just did it in the calculator and added it all together. And the reason why I didn't write it down is because since our length is 1, essentially, that's not going to affect this. So I went ahead and squared each of these and added it together. Okay. All right, and if you do that, you are going to get 170. Okay, so you probably noticed something that is a little bit unique that's happening. And this might remind you of our time we worked with limits. So the greater the subintervals, the closer this gets to approaching the limit. Okay. So and the limit looks like it's about 170.7 or so. Okay. So why does this happen? This happens because when I have a curve like this, the smaller the rectangles that I use, the closer it gets to the real area. Okay, so that's why we're allowed to do this. Okay, so let's go ahead and do a little bit more. So what this is telling me is we are going to create our rectangles, and our rectangles are going to be equal divisions, okay? So let me go ahead and give you an example with this. So in this case, our interval is 1 to 9, and it wants us to find these x values. So what we're going to do first is we are going to subtract. And when I do that, I'm going to get 8. And then this is telling me that I'm going to have four intervals. So we're going to divide that by 4. And that gives us a length of 2. You will also see this written as a triangle with your x. Okay, so that's what this stands for. Okay, so my initial value is 1. Okay, my length is 2. So I'm going to add 2. Which is going to give me 3. Okay, so what that 3 is telling me, that is my x1 value. Okay, so then we do the same process. We say 3, we're going to add 2 again, and that's going to give me 5. And 5 is going to be my x2 value. So then we add 2, we're going to get 7. 7 is my x3 value. And x3. And that's my x4 value. Okay. So I have x1 is 1. x0 is 1, x1 is 3, x2 is 5, x3 is 7, and x4 is 9. Okay. Okay. All right, so making these rectangles is a process that we call the Riemann sum. So we have a left Riemann sum when you only care about the left endpoint of the interval. Right cares about the right endpoint. Clark, get off the counter. And the midpoint, obviously, is the midpoint of the two intervals. Clark, please get down. Thank you. Okay, so here's just an image for what it looks like. So you will notice that each of the left points of my interval is making the bound for the rectangle. And here, each of the right points is making that bound. And then the midpoint is making the rectangles for this one. Okay, so what we're going to do, I think I might add another slide here because this just takes a little bit of room, and I want to make sure that I write it so that you guys understand it. So we're going to do this problem, but I'm going to make a chart for this because you're going to notice the next 3. I thought it was the next 3 examples. Did I delete something on accident? Oh no. Okay. Yeah. The next 3 examples deal with the same problem. We're just going to do the left, then the right, then the midpoints. Okay. So key things here. Our function is sine x. We are going between 0 and pi over 2. All right. And in this case, we're going to do left, and my interval is 6. So I'm making 6 subintervals. Okay. So where's my pen? Okay. All right. Here we go. Oops. Okay, so in this case, we are starting with 0, and we're going to pi over 2, okay? And so just like before, we are going to subtract these two, which is going to end up giving me pi over 2. And then since I want 6 sub-intervals, I'm going to divide that by 6, which is going to give me pi over 12. Okay, so let's go ahead and set the chart up. So we're going to start with our initial value. 1, 2, 3, 4, 5. So all right, we're going to start with left. Okay, so the very first number that I have is 0 to start with. All right, my length, should have labeled that. This is my change in x, this is my length, is pi over 12, which means every single time I'm going to be adding pi over 12 to get the right bound. So I'm going to go ahead and write that down just because that way it's all color-coded and beautiful. Oops. Come on. There we go. Plus, oh, I should put a plus. All right, here we go. Okay, so then we're going to get pi over 12, okay, which tells me that this is pi over 12. And I'm going to add it to pi over 12, so I'm going to end up with 2 pi over 12, which is pi over 6. So pi over 6 plus pi over 12. So it's easiest to think about it with 2 pi over 12 plus pi over 12. So then that's going to give you 3 pi over 12. Or pi over 4. So then pi over 4 plus pi over 12. So essentially I'm thinking of 3 pi over 12 plus pi over 12, which is going to give me 4 pi over 12. And that reduces down to pi over 3. So pi over 3 plus pi over 12 equals 5 pi over 12. And 5 pi over 12 plus pi over 12 is going to be 6 pi over 12. And that is going to essentially be pi over 2. And actually, I am done and don't need to finish this part, okay? Because now I have my 6 intervals. So we have 0 to pi over 12, pi over 12 to pi over 6, pi over 6 to pi over 4, pi over 4 to pi over 3, pi over 3 to 5 pi over 12, 5 pi over 12 to pi over 2. Okay. Now, the next thing that I'm going to go ahead and do is I'm going to find my midpoints. So again, it's probably going to be easiest for me to look at the terms that have 12 in the denominator just because that makes it a little easier. So essentially, I'm still going to do pi over 12 plus 0, add that up, divide by 2. I'm going to get pi over 24 for the first one. Pi over 6 plus pi over 12. Divide that by 2, I'm going to get 3 pi over 24. Now you might be noticing the pattern. Each time I'm increasing by 2 in my numerator. And I could simplify this, but I'm not going to. All right, let me move this out of the way. Oh, come on. Oh, here, there we go. All right, so we have 5 over 12, 7. pen's not working. I'll try on the next side. Okay, so 5 pi over 24, 7 pi over 24, 9 pi over 24. Okay. So let's see if the pen comes back on the next slide, and if not, I will restart this. Okay, so we're starting with left. So when we're starting with left, that means looking at these values, I'm going to be using 0, pi over 12, pi over 6, pi over 4, pi over 3, and 5 pi over 12. I'm not using pi over 2 because that's the right bound of this set, okay? So what we're doing is multiplying our length, which is, okay, yeah, I need to restart that. All right, so let's try this again. All right, so we are caring about the left intervals. And so what we're going to do is our length, that was pi over 12, right? And so then what we're going to do is we are going to take and we are going to multiply that by the value of each of the left bounds of our interval substituted in to the sign. So actually, I'm going to write it like this. So sine of 0 plus sine of pi over 12 plus sine pi over 6 plus sine. You hear random singing, it's Madison. She was singing Bingo and the Finger Family song. If you don't know either, you probably know Bingo, but if you don't know the Finger Family song, you should look it up. It's one of those things like Baby Shark that the kids get addicted to. Okay. So you can just straight up plug these into the calculator. You don't have to use the unit circle to find the values because it's going to be quite a nice decimal. And by nice, I mean not really nice. So about 0.863, okay? Okay, so then we're gonna do the exact same thing on the next slide, except instead of left, we're gonna do right. So now what we're gonna be doing is looking at pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2, okay? So the process is relatively the same. Still going to have pi over 12, my length in front, multiplied by sine pi over 12 plus all right, so if we plug that into our calculator, we're going to get about 1.125. Okay, so I want you to take a look at these graphs. And I want you to tell me what you are noticing. So left is going to underestimate. Where's my pen? Oop. Oh my gosh, what the heck did I just do? Okay. It's not working again. Okay, so this is going to underestimate. All right, and you can tell that because there's these white blanks here. Now this is going to overestimate. Okay, because there's extra above here. All right, so now let's see what happens when I do the same thing with the midpoint. So I am still going to be using my pi over 12. Okay, so pi over 12, and we're going to multiply that by sine of pi over 24. Or actually, I'm going to copy and paste this so I don't have to keep trying to find it. All right, come on. All right. Just scoot over. There we go. All right, so the next one is what? 3 pi over 24 plus 5 pi over 24 plus 7 pi over 24 plus 9 pi over 24 plus 11 pi over 24. Did I not write that one down? Let me go back because I don't know if I did. Yeah, it looks like I didn't because my pen was all messed up. So 1, 2, 3, 4, 5. Yeah, I only wrote down part of it. Okay, so 11. Let's fix that now. Pi over 24. Okay. All right, so I'm going to plug that into my calculator. And if I do that, I'm going to get approximately 1.003. Okay? So what this is essentially telling us is when you're doing these problems, your left is going to underestimate, your right is going to overestimate, but your midpoint kind of is a nice balance between that because essentially, even though a little bit is over, if you essentially like take that piece and put it there and take that and put it there and take that and put it there, it's a pretty good match for the true area. Okay, let's do another one. So in this case, we're going to find the area or estimate the area using left and then right, okay? All right, so for left, we are going to be using 0 to 1.5. And the reason why I know that is because these values here are my bounds, and I have 4 subintervals. So essentially my first interval is 0 to 0.5. My second interval is 0.5 to 1. And then my next interval is 1 to 1.5. And then my next interval is 1.5 to 2. Oops. So essentially, the items that I've highlighted in yellow are all of my left ones, okay? So I have started the setup of this one. What I want you to do is I want you to go ahead and try this one on your own. If you are successful, you will end up with left being 7 and your right being 9.5. So I want you to try those, and if you don't get it, let me know, all right? So it's a little tedious and cumbersome to write these out. So what we can do is we can use sigma or summation notation. So your K is going to be your index. And in this case, the lower limit is 1. That's where we start. The upper limit is 10. Now we have a couple of different rules. So the first one is just saying that if you have a number in front, you can take that out. This is saying that you can split them up into 2 summations. This is the same thing, except it's subtraction. All right, and here, just a little bit more properties. If you have just a constant number, you're going to multiply that constant number by the upper bound. And then this is what I want you to pay attention to, these 3 guys right here. So this is the shortcut way so that you don't have to do the entire problem. So let's say for this one, or let's do this one even. So this one, let's say I have n, and my n value is like 5 million. So essentially, if I was starting at 1, it would be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. All adding, all the way up to 5 million. I don't know about you, but I don't have time for that. I barely have time for anything right now. So that's too much. So we're going to use these shortcuts to help us evaluate these problems faster. All right, so let's do a little throwback. You did this in, gosh, when did you do this? Do you do this in Algebra 1? I don't remember. I know you definitely do this in pre-calc and maybe Algebra 2, but to be honest, I don't remember. All right, so we have a generic equation to figure out the rule. So what the generic equation is A sub n equals A sub 1 plus B, plus D plus D times n minus 1. Okay, so what this equation is saying is your A1 is your first term, your D is your common difference. So what's the difference between 4 and 5? I told you, sorry. What's the difference between 4 and 9? It's 5. Between 9 and 14, it's 5. Okay, so our common difference in this case is 5. So we can actually solve this equation now. So we would say A, come on. My mouse doesn't even want to work. I think it's probably the camera. Madison's camera. All right, common difference, 7, and then you're going to say n minus 1. Not 7, it's 5. Can't multitask. All right, so then we're going to get A sub n equals 4 plus 5 n minus 5. And you're going to simplify that, so you're going to end up with A sub n equals 5n minus 1. Okay, so that's my generic equation. So if I had, I wanted to know what the 6 value was, I could plug in that, and I could get my answer. Okay, so we have our equation, which means we have under math. Yeah. Oop. Oh, I wanted you over there. Of course, you just, you know. All right. Actually, let's do this. Copy this. Come on. It's like mad at me. Okay. Copy this. Put it over here. Actually, all right, whatever. So, all right, making it work. Okay, so now we need to figure out what the first term is and what the ending term is. So in this case, what you're going to do is you're going to set this equation equal to 4 to find the first term. Oops. So you're going to say 5n minus 1 equals 4. So we're going to get 5n equals 5. So we're starting with 1. And 1 goes here. Okay, and now we're going to do the same thing with our ending term. So we're going to say that 5n minus 1 equals 44. So we're going to get 5n equals 45. So n is 9. Okay, so we're ending at 9. All right, there is another problem like this. So you are going to do it and let me know what you get because I'm curious. All right, now let's actually do the problem. Now she's singing the alphabet. Okay, so in this problem, it now looks like it's showing up. Before it didn't look like it was showing up. Okay, but now it's here. All right, good. So what we're going to do is we are going to start at 1 and we are going to plug that in, and then we're going to add those 3 numbers together. So you're going to plug in 1, plug in 2, plug in 3, and then add those 3 numbers together. So I'll give you a minute to do that. Actually, just pause the video and do that. All right, so if you plug in 1, you should get 4/3. If you plug in 2, you get 6/3, which is 2. And if you plug in 3, you get 8/3. So then you're going to add 4/3 plus 2 plus 8/3, and that is going to give you 6. So your answer for this is 6. Okay. All right. Next one. Last one. Okay, so the first thing that you're going to want to do with this is you're going to want to split it up. All right, so essentially then I'm going to have, okay, oh, interesting that I put it right there. 2p plus p squared. Okay, so remember how we learned those rules? These guys? Okay. So we are going to use this one for the 2p part, and I'm actually going to bring the 2 in the front, okay? Notice your n is always going to be upper bound. All right, and I'm going to use this one for the squared part. So let me actually see if I can just copy and paste each of those onto the next slide. Okay, bada bing, bada boom. Good. Okay, so the 2 essentially can come into the front here. That. Okay, so then this one is going to look like this. So we're going to use this rule, and our upper bound is 10. So we're going to say, oops, I was still on. So 10 plus 1, and that is all divided by 2. So I'm going to do that and do this. Okay, looks pretty good. All right, and then the other one is p squared. So it's essentially like me having k squared. So we're going to say plus, and then I'll write over here. So we have 10 times 10 plus 1 times 2 times 10 plus 1, all divided by 6. All right, so I got 110 for the first term, and I got 385 for the second term, and so I added them together to get 495, and that's it.